Welcome to my course. Here you'll learn how to create a complete C++ and Blueprint game from scratch. The project will be fully finished, including a main menu with settings that are saved to a file, such as screen resolution. There also will be localization support, so you can easily add new languages to your game. You'll create a full gameplay level, where you'll practice designing game logic. I also show you my convenient workflow for combining C++ and blueprints in Unreal Engine. Finally, you'll experiment with materials and learn how to use them in your own projects to create cool visual effects. By the end of this course, you'll have a complete Unreal Engine project and the skills to start building your own games. You can download Visual Studio from the official website. I've included the link in the description. When you open the Visual Studio installer, click Modify and select the components recommended in the Unreal documentation. I've also included that link in the description. We are ready to create a project. Open Unreal Engine and create a blank project. Ensure that you selected C++ configuration. I'm using JetBrains Rider as my IDE and highly recommend it for working with Unreal Engine. It's free for non-commercial use. If you prefer to stick with Visual Studio for now, that's fine. Open your projects folder in File Explorer and right-click the .sln file. If you followed my setup, it should be called asteroidgame.sln. Open it with either Visual Studio or Rider. If you don't see a .sln file, right-click the .uproject file and select Generate Visual Studio Project Files. In every new project, I like to do the following setup. I open the editor preferences and change the asset editor open location to the main window, so new windows are automatically attached to the main window and don't open as new windows. I also created an assets folder and three folders inside it: materials, meshes, and textures. Now we are ready to download assets. First of all, open the Space Sphere maps and select the one you like. In my case, I selected HDR Subdue. Then download the Earth model and asteroids. Let's import those assets now. Drag the HDR image to the content browser, then drag the texture for the Earth planet, and then drag the planet.fbx. When you import the FBX models, a new window opens. In this window, ensure that Recomputate Normals is disabled. Then click Import. Then open the asteroid folder, simply drag the .glb file and click Import. This should generate a new folder in your content browser. Now let's set up those imported files. Open the HDR image and select the maximum texture size to 2048. This will be enough for our project. Then rename the planet material to m_planet and open it. Inside you'll see a couple of nodes we are interested in, such as diffuse color map. You need to click on it and select the planet texture. Then you can see that the planet static mesh has been updated with the correct colors. Now navigate to Materials folder inside the Asteroid folder and create a new material with the name m_asteroid. Inside the material graph, you can press Alt plus space to open the content browser pop-up. In this content browser, select the asteroid textures and drag them to the material graph. Connect the blue one to normal, the gray one to base color, and the yellow one to metallic. Then save this material. Now open every asteroid static mesh and select this newly created material. Drag any static mesh to the viewport. When this mesh is selected, you can see its pivot, the origin basis with 3 direction arrows. This pivot has the wrong offset now. We want it to be in the mesh center. Let's fix it. Select modeling mode, click on X-form, click edit pivot and click on center. Then press accept in the viewport. Do the same for all the asteroids meshes. Let's create our main level. Navigate to the File menu, click New Level and select a basic level. In this level, delete the exponential fog, skylight, sky atmosphere and volumetric cloud. We are going to make our space sphere. For this, create a new material and call it m underscore spacebox. Inside this material, change the shading model to unlit. Unlit means that this type of shading won't react with the light. Then open the context menu by pressing the right mouse button and select reflection vector WS. Then hold 1 and press the left mouse button. Connect this zero value to custom world normal. Then create a texture sample. We are going to use our HDR image there. But before we can do it, we need to make some adjustments. Open the HDR image and ensure that the texture group is set to Skybox and the compression settings are set to HDR. Then select this HDR asset in the texture sample and connect its RGB to emissive color. After this, save the material. Now select the sky sphere in the outliner and drag the spacebox material to its material slot. Now you should see our space image, but we also have this exposure and we don't want to have it. We need to override the post-processing settings. For this, add the post-process volume. In its details panel, type extend and ensure that this settings is toggled. Then type exposure and set min and max EV to 0. Now we should have a much better result. We can also delete the floor because we don't need it. Also reset the position for the player start and directional light. Then you can move the directional light up a bit so it doesn't overlap with the player start. Then reset the position for the post-process volume and move it a bit as well. Then drag the planet mesh to the viewport and move it a bit farther away from the player's starts. Then select the directional light and set its intensity to 1.5. That's it for our basic setup. You can save this level, call it L underscore main and press save. I already did it, so I just close this window. If you are using Rider, you need to open the editor preferences and set it in the source code editor. Now we are ready to make our first C++ class. Navigate to the tools and press new C++ class. Then select a pawn. A pawn is an actor that can be processed and receive input, and call it asteroid game pawn. This will be our player. Then click create class. You should see this class in your IDE. If you don't have it opened, you need to open the project solution in the projects folder. I will not type code live. I will just explain what I added and why. First of all, I have forward declarations for a scene component, static mesh component, and camera component. We use forward declarations for our pointers. In C++, you should try to use them as much as possible, and use include only when you have to, such as in cases where you use a class as a member variable and not as a pointer. Then I have a constructor and setup player input component. We'll be using it a bit later. Then I have begin play and tick functions. Those three functions are provided by Unreal Engine for us. Setup player input component is used for input. Begin play is fired only once when the actor receives begin play, and tick is called every frame. Then we have Earth rotating speed, and it is marked as your property. This is very important. Unreal Engine provides us with reflection, which allows us to export variables to the editor, so we can configure them instead of hard coding values in the code. I'll attach the link with your property specifiers. In our case, edit defaults only means that we'll be able to configure those variables only in the asset window, and blueprint read only means that we'll be able to read this variable in blueprint if we need it. Then I have a t-object pointer for the scene component called pawn root component. This will be our root component. Unreal Engine recommends that we use t-object pointer in header files for any u-object pointer. Then I have another scene component called rotating point component. It will be our rotation root for the turret. Then I have another scene component pointer called turret spawn point. We'll be spawning our turret in this location. Then we have a static mesh component called earth mesh component. We need this component to display the earth mesh. And finally, we have a pawn camera component. This will be our player's camera. In the CPP file, we include our components. If you don't know where the include is located, you can either press F12 and see its location, or check it in the Unreal Engine documentation. In the constructor, we simply create our components by calling create default subobject. After creating the root component, we set the root component. For other components, we simply call setup attachment. Begin play has default values for now. In tick we are adding a rotation for our Earth. For this, simply create an F rotator and pass Earth's rotating speed multiplied by delta seconds as the second parameter. Delta seconds is the time between the current and last frame. We need to do this so the rotation stays the same on different computers and doesn't appear faster if you have more FPS. Then you should build your project from the IDE. When you've built the project, open the project settings and set our L underscore main as the editor startup map and as the game default map. Then create a blueprint folder in the content browser and click on blueprint class, select asteroid game pawn and call it BP underscore player. Then open it, click on the earth mesh component and select our SM underscore planet. Then set 23 for the Y component of rotation, select the camera component, move it for 400 units, and press compile. You can also click on the three dots, hover over save on compile and select on success only. Then drag BP underscore player to the viewport and reset its rotation. Then you can press play and you'll see the Earth rotating. We are going to create a game mode now. Game mode is a part of the Unreal Engine gameplay framework. It is responsible for setting default classes for a level, such as the default pawn, pawn controller, etc. We can access the game mode from each actor, which is very convenient. Click on C++ classes, then click Add Import Content and select New C++ class. In the opened window, select Game Mode Base and call it Asteroid Game Mode. This will be an empty class for now, so we can simply build our project. We'll use this game mode as a base class for our blueprint. In the blueprint folder, create a new folder called game mode. Then create a blueprint class, select our asteroid game mode and call it BP underscore game mode. Then open it, change the default pawn class to BP underscore player and compile it. Then open the world settings. If you don't see this window, navigate to the window tab and open world settings there. In the world settings panel, select BP underscore game mode as the selected game mode. Now delete the player from our level because it will be automatically spawned by the game mode now on player start. Press play and you'll see our player with the view from its camera. We are ready to create a turret, but first let's create its mesh. Open modeling mode and add a box. Place it in the viewport, then set its width to 25, depth to 10 and height to 10. Press accept. Navigate to the created mesh and rename it to sm underscore turret base. Next, add a cylinder. Set its radius to 3 and its height to 10. Press accept and rename this mesh to sm underscore turret gun. Switch back to selection mode and reset the position of both meshes. Move the cylinder upward so it sits above the base. Select both meshes and from the actor menu above, hover over merge actors, then select merge. Name the merge mesh turret. Now we have a single mesh that represents our turret. Now let's make C++ classes for turrets. This part introduces inheritance and polymorphism. Our game will feature different turret types with unique logic, and this is exactly the case where polymorphism becomes useful. I have created two classes, turret base, which acts as an abstract base class, and a standard turret which inherits from turret base. The turret base class contains forward declarations for scene component and static mesh component. It is marked as abstract, which means it cannot be instantiated directly, but instead serves as a base prototype for the inheritance chain. Inside this class, I define a polymorphic function called fire. In Unreal Engine, we don't explicitly mark such methods as virtual, but instead use the blueprint native event specifier. This allows the function to be overridden either in C++ child classes or in Blueprint subclasses. This class also defines two member variables, one for the turret rotation component and one for the turret mesh component. In the constructor, these components are created and attached to the actor. An important detail is that every function marked as a Blueprint native event must also have a corresponding underscore implementation function, such as fire underscore implementation, because the Unreal Reflection system looks for that naming pattern when binding the actual implementation. The standard turret class inherits from turret base. It is also marked as abstract, because in the game we will use a blueprint class derived from it with the proper setup. This class overrides the fire implementation method, and for now the implementation simply prints a debug message. We can integrate the turret into the asteroid game pawn. First, I added a forward declaration for turret base inside the pawn class. Then I created a T subclass of turret base member, which allows me to select which turret class should be spawned. Alongside this, I keep a T object pointer to store a pointer to the active turret instance. Inside the begin play function, I spawned the turret using the class specified in the T subclass of variable. To be safe, I added an ensure check to verify that a valid class is assigned before attempting to spawn. After the turret is spawned, I attach it to the turret spawn component on the pawn. At this point, the pawn is fully capable of holding and managing turrets. The last step is creating a blueprint turret in the editor. I started by creating a folder called actors and then another folder inside it called turrets. Within this folder, I created a new blueprint class based on standard turret and named it BP underscore standard turret. I assigned the sm underscore turret to its turret mesh component. When I was looking at the mesh in the viewport, I noticed that its pivot was centered, but for gameplay we want it to be bottom centered. To fix this, I dragged the turret mesh into the viewport, opened modeling mode and adjusted the pivot point to the bottom center. With that change, the blueprint turret is now ready to be used in the game. Next, open BP underscore player and select the turret spawn point component. Move it upward by about 110 units, then click on the root element and in the details panel assign a class for the turret. In our case, this will be BP underscore standard turret. Now press play and you should see the turret mesh correctly attached to the planet. To test if the fire function works, open the event graph in the player blueprint and create a key event for the number 2. From this node, call getCurrentTurret and then call the fire function. Connect the nodes together and now when you press the number 2, you will see the default firing message appear. This is a good moment to demonstrate how powerful our setup really is. I duplicated the standard turret and named it BP underscore test turret. Inside this blueprint, I pressed the override button, selected the fire function and connected a print string node that outputs test turret. Then in player blueprint, I switch the turret class to BP underscore test turret. Now pressing the number 2 shows the test turret message instead. This means that in the future when we want to change turret behavior, we can simply use a default turret class without modifying the player code. This flexibility is exactly the benefit of the blueprint native event approach. Once finished, I reset the default turret class back to BP underscore standard turret and deleted the test turret blueprint. It is now time to set up proper input handling. We will use Unreal's enhanced input system for this. In the C++ side, I started by adding forward declarations for input action value, input action, and input mapping context. I also created several member variables: turret rotation speed, player mapping context, rotate action, and fire action. The mapping context defines which keys are bound to which input actions. And we will connect these actions to our rotation and firing functions. For this purpose, I have written three functions: rotate input, rotate release input, and fire input. I also created a turret rotation vector variable to track rotation input. Inside the C++ file, I included both enhanced input component and enhanced input subsystem. In begin play, I added our player mapping context to the input subsystem. Then inside setup player input component, I binded these actions. The started event is triggered when a button is pressed. Triggered corresponds to when a button is being held, and completed is fired when the key is released. The rotate input function simply stores the input vector. For example, pressing left produces a vector of -1 on x and 0 on y, while pressing right produces 1 on x and 0 on y. In the release function, I reset turret rotation vector back to 0. In the fire input function, I check if our turret pointer is valid before calling fire. It's best practice to use isValid instead of comparing against null pointer, because isValid also checks if an object has been marked by the garbage collector as pending deletion. Finally, in the tick function, I update the turret rotation based on the input vector. We are now ready to set up the input assets. Inside the blueprints folder, I created a new folder called input. In this folder, I added an input mapping context named imc underscore player and two input actions, rotate and fire. The fire action uses the digital value type, which means it only produces boolean results, such as pressed or released. The rotate action, however, uses the vector 2D value type, because we want to capture directional input values such as pressing left or right. Next, open the player mapping context. Add a new mapping. Select fire and bind it to the spacebar. Then create another mapping for rotate. For the first binding, assign the A key and add a negate modifier so that pressing it gives a value of -1. Add another binding for the D key, which produces +1. Save the mapping context. Now open player blueprint and assign the new mapping context with its input actions. When you press play, you should be able to rotate the turret using the keyboard. At this stage, the default turret doesn't look very appealing, so let's improve its visuals by creating a material. Inside the materials folder, create a new material and name it m underscore turret. Set its shading model to unlit, add a vector parameter node, call it turret color, choose any color you like, and connect it to the emissive color input. Finally, open the sm underscore turret mesh and assign this material to it. Now the turret has a clean, glowing appearance, and it looks much better in the game.